I'm going to talk about a couple things. First of all, I want to give you guys a little bit of a background on electric power systems, right? Something you've been dying to know more about. And second, I'm going to tell you a little bit about my entrepreneurial journey with the two companies that Armin mentioned. And then third, I want to really get into and just talk about where some of the energy business is going. And hopefully, I'm going to finish up quickly so we can just have discussion and Q&A, okay? So I'm going to sort of go through this. If you have any questions, obviously, please just throw up your hand and let me know that we can stop. So I'm going to focus on electricity. There's a lot of issues in energy today, but electricity is certainly one of the biggest and certainly is the dominant form of energy delivery. And maybe I'm not doing this right. Okay, forget that. So the traditional power systems that you're familiar with, you have big central power stations, generation sites, and so forth. You have transmission networks, which are the big tall towers that you see all over the rural areas in particular, less often in the urban areas. But then once you get into cities and towns and so forth, you have what's called a distribution system, separate from a transmission system, and then that's what delivers power down to your home. So the wires that run down behind your house, that's part of a distribution system. The huge tall towers that you see, that's part of a transmission system. There's big differences in the way power is conducted at very high voltages on those large, tall power lines, and 13,000 volts or so at the power lines that run around your houses, compared to hundreds of thousands of volts that might run around the transmission systems. Technically, very different. So I have a couple questions here I want to ask you guys. Do you guys know, or anyone have a feel for what the biggest source of energy is for electric power systems here in California? Okay, all right, yeah, absolutely right, because that's something that's actually been transitioning quite rapidly throughout the US. Okay, but in California in particular, it's been very busy over the last few years. We've actually seen a big drop in nuclear as one of the biggest power stations in the US. Actually went offline down in Southern California. That's been replaced by natural gas. Obviously, coal is being decommissioned wherever possible, and renewables are coming on strong, and particularly in California because of incentive programs we have here in this state. How many of you are from California? Okay, so I'll talk about California like you all have no idea about California, but it's representative because what it's doing is actually leading a lot of the world in the way energy is being transformed, especially in the electric power sector. So in this whole distribution system, there's a legacy of regulation because nobody wanted to have lots of wires running down every street. So they basically put in place monopoly services, right? So there's one distribution company that provides electric power in a given area rather than three running wires down the streets trying to compete for your electric service business. Okay, so but based on that, how many electric utilities do you think we have in the US? Number C? Anyone else have a guess? Okay, over 3,200. Okay, because PG&E is the largest utility here in Northern California, but the city of Santa Clara has its own power system. The city of Palo Alto has its own power system. Rural cooperatives in actually the middle of nowhere, California, have their own power systems. And they all run as separate little businesses with all the costs associated with that. It's horribly inefficient. Wasn't my idea, but basically it's the way things have evolved. So every little group sort of built their own power systems, and over time, some of them have combined. And so today in the US, probably the 50 largest companies serve the bulk of the US, but we still have thousands of individual small companies running their own power grids. Okay, there's 20 regional transmission systems. This is where power is transmitted from large power stations and traded across long distances using the transmission network. And in some states, they've been able to open up power purchasing to retail competition. That is, you could buy power from a different supplier. So even though PG&E may run the wires to my house, I can choose a different supplier who may offer me some sort of different pricing bundle, green component, source of energy type of portfolio. So how many states do you think actually have that kind of retail competition? 15. 15 is right. Okay, so 15 states, including the District of Columbia, if we want to cheat and say there's 16, have actually opened it up so that you as a retail customer can elect to buy your power from a supplier. And that supplier may own a big power plant somewhere, and he'll pay transmission and distribution fees to deliver the power to your house. And you pay then the net total to the guy who actually sold you the deal. So in Texas in particular, it's a very competitive market. People can switch their suppliers every 30 days, and they can then shop around for the best power options that they can they can get from the different suppliers in the Texas market. So the reason that's important is that power is generated from all of these different power systems, but it has to follow the load. That is, when you turn on that light, you're creating a load. If you didn't step on the light bulb, right, that light bulb's going to go on, and you're going to draw power, and that power has to be sourced. And if people are doing that all the time, randomly all the time throughout the day, businesses are doing it. Electric vehicles may be charging, and all these things are now being, they're essentially purchase transactions that you're making when you turn on that switch or you turn on that particular device. And in order to supply the product that you just bought, right, the generator has to, in real time, be able to deliver that power into the grid. It's a very complex system. There's not a lot of real-time controls that go on, but basically the systems are designed to maintain the voltage level and the power frequency that's going into the system, so that when these things happen, all the controls that man the generators and the transmission systems react to all of those different loads. Because of that, during peak times of the day, when power gets used a lot, they fire up new generation, right? So there may be some generator that's idle, and then all of a sudden the load starts to grow, and then they start putting more energy into that generator, usually by burning, natural gas, maybe coal, and they turn on more power from that generator to supply that need. Because of that, the costs go up, right? Because now you don't have a fixed cost anymore. The generators are now having to consume more fuel. You have more generators online. So the power price in the wholesale market, the cost of power is varying continuously throughout the day. So in the wholesale markets, which are usually at the transmission level, people are buying and trading energy, just like they're buying and trading any product, right? And they're basically trying to schedule that generation to go with what they believe to be the load in the different areas where the power is being delivered. So think about that from a market perspective. You've got a lot of active transactions going on in the market where the price is varying all the time. Okay? Now, what we see as consumers, we see a bill. And typically we see a flat price. Now there's fundamentally a problem with that, because if I don't have a price signal, how do I know what I'm doing when I make my purchase decision? How do I know that I really want to buy that power if it's at a point where it should be really expensive? And the fact of the matter is it's not. Consumers are generally protected from that. The wholesale trading and so forth gets lumped in to a bulk price, so we can all enjoy a flat price, but essentially what's happening is they're hedging. They're basically hedging that power price in the market, and they're giving you a flat price. There's a cost to that hedging, right? And you're paying that. Okay? So what's been happening now is people are saying, well, there may be some more effective ways, rather than hedging that and making it hidden from you what the actual costs are, and you're paying for those costs anyway. Let's give you more transparency in the market. Let's give you a view into what the real costs are so you can make a more informed decision about how and when you use power, because these costs are varying all the time. So that's kind of the impetus for thinking about an open market where power transactions can be more transparent with real understanding of what the prices are and what the costs are at the consumer level.